Hi students, welcome to my YouTube channel Fun with Chem. Today I'm going to discuss May 2024 Unit 1 chemistry paper, right? So we'll see the first question. How many atoms are there in 10 grams of? So normally we know in 1 mole we have Avogadro number of atoms. So they have asked how many atoms are there in 10 grams of methane. So we need to find the number of moles in 10 grams. So when you take 10 grams divided by 16, 16 is the mole. One carbon is 12, 4 hydrogen, each hydrogen is 1 into 4, it's 4. So you get the molar mass as 16. Then you get it as 0.625 moles. Then if 1 mole contains this much of atoms, we need to find how many molecules, 1 mole contains Avogadro number of molecules. We need to find how many molecules are there in 0.625. So if you take 1 molecule of methane, there are 5 atoms, 1 carbon and 4 hydrogens. So you need to multiply it by 5 to find the number of atoms in 10 grams of methane. So the correct answer is 1.88 into 10 to the power 24. Answer is C. Remember that you have to multiply it by 5 in order to get the number of atoms in methane, because one methane molecule has 5 atoms. Then we'll see the second one. What is the maximum volume of butane that can be completely burnt in 39 cubic centimeter of oxygen? Here, children, we need to assume that the number of moles. So if you take the ratio, the stoichiometric ratio between butane and oxygen, it is 1 to 6.5. So when you have 39 cubic centimeters of oxygen, that is for 6.5, then we can easily find how much is for 1. Here divide 39 by 6.5. So you get the answer as 6 cubic centimeters, and the correct answer is A. Then we'll see the third one. The question is about limonene. What is the molecular formula of limonene? So if I draw the number of carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 carbon atoms. In the same way, I'll try to draw the number of hydrogens. Each carbon should form 4 bonds. So 1, 2, 3. This carbon has already formed 4 bonds. So no hydrogens in that. 1, 2. This should have only 1 because 3 bonds are already there. So when you're assigning the number of hydrogens, you have to check whether each carbon has 4 bonds. So if I count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. C10, H16, the correct answer is B. Limonene is completely hydrogenated by hydrogen. Then you need to find the empirical formula. So children, if it is undergoing hydrogenation, definitely the 2 double bonds will not be there. Okay. Carbon atom, right? So if I take this carbon, 3 hydrogens, This has only 3 bonds. So 1. Here I have to put 2, 2, 1, 2, 3. Here also 1. Likewise, you have to put. Then we'll count the number of hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 18, 19, 20. So number of carbons will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the molecular formula is C10H20, but they have asked us to find the empirical formula, which is CH2. So we'll see whether that answer is there in the, yes, among the answers. So you can see D is the correct answer as the M is CH2. What is the best definition of a hydrocarbon? So, children, that's direct theory, right? You should know that they are compounds containing carbon and hydrogen only, right? This is wrong because of oxygen. Single bonds with oxygen also, you can have single bonds in alcohol, right? That's a single bond, right? Because of that, that is also wrong. A mixture, no. It should be a compound. The difference between mixture and compound, if you take air, it's a mixture because it has carbon dioxide, argon, oxygen, nitrogen. But if you take a compound, the atoms have chemically bonded to form one product, right? So that's the difference between a mixture and a compound. Then this one, you have to find the atom economy. So you know the ratio of atom economy, the equation for atom economy, which is given by mass of the desired product divided by the mass of the total product. So when you're taking the total products, you need to consider the stoichiometric ratio as well. So here for fermentation means fermentation product is the alcohol, right? So if you take the atomic mass of alcohol, we have 2 carbons, 24, 3, 4, 5, 6 hydrogens and 1 oxygen, which is 46. Likewise, there are 2 atoms, therefore it becomes 92. Then the total number of total mass of the products will be 92 plus 88, which is 180. Then out of 180, only 92%, 92 is ethanol. Then we need to find it as a percentage. We are getting it as 51.1%, and the answer is D. What is the percentage atom economy? So children, when you see only one product, so there's no doubt it is 100%. Right? So the correct answer is D. This question is about electronic configuration. What is the electronic configuration of an atom of calcium? So we know atomic number of calcium is 20. 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. Therefore, if I write it as the shorthand notation, as they have given in the shorthand notation, I can write argon as 18 is the electronic configuration of argon. Therefore, the correct answer is D, argon and 4s2. What is the electronic configuration of Cr3 plus ion? So, even though we write according to the 1s2, 2s2 form, only chromium and copper are different, right? Because there's a small change in that. When you write the electronic configuration, 2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. So if I write together, the three orbitals together, I can write 3p6, 3d5 and 4s1. So when I'm removing an electron, when I'm removing 3 electrons from chromium, I should remove it from the out shell, right? So it is 3d5 and 4s1. So when I'm removing 3 electrons, one 4s electron will remove and 2 from 3d. So I will get 1s2, 2s2, 2p6, 3s2, 3p6 and 3d3. Right? So this is the electronic configuration of argon. So after removing 3 electrons, I'm getting argon and 3d3. So the correct answer is B. So if I explain about copper, right? Copper is the other term that has a different electronic configuration like chromium. It is 1s2, 2s2, 2p6, 3s2, 3p6, then 3d10 and 4s1. So only in chromium and copper you have 4s1 because they, in order to become stable, one electron from 4s will go to the 3d energy level. Then this has the half stable electronic configuration. This will have the completely filled electronic configuration. Then we go to the next question. This question is about bond angle. We need to find the bond angle of BCl3. So first, we need to write the electronic configuration. Boron is 5, 1s2, 2s2, 2p1. If you take the second energy level as the outermost shell, it has only 3 electrons. So as we have 3 chlorine atoms, we know all 3 electrons will bond with 3 chlorine atoms. So I can draw the dot cross diagram of Cl3 like this. Then if I find the number of bond pairs and lone pairs, 3 bond pairs and 0 lone pairs. So in your student book under topic 3, there's a table. So when you see 3 bond pairs and 0 lone pairs, the shape is given as trigonal planar. So when you have a trigonal planar shape, the bond angle is 120. So if you take the second one, what is the expected bond angle of ammonium ion? So ammonia and ammonium ion are two different compounds, right? So ammonia is like this. When it's forming ammonium, a dative covalent bond will be formed. Therefore, ammonia will have 4 bond pairs and 0 lone pairs. Therefore, when you have 4 bonds and 0 lone pairs, the shape is tetrahedral. So the bond angle of a tetrahedral one is 109.5. Then the next one, what is the expected bond angle in an oxygen difluoride molecule? So the first step is to write the electronic configuration of oxygen. One is 4. That means there are 6 electrons in the outermost shell of oxygen. And we know as it has 2 fluorine, 2 electrons will undergo bonding. Then the rest will be 1, 2, 3, 4, 5, 6. So you have 2 bond pairs and 2 lone pairs. Shape is V shape, or we can call it angular. Therefore, the bond angle will be 104.5. So these are direct theory, children. Everything is given in your student book. Which is the strongest oxidizing agent in these displacement reactions? So normally children, we know if you take group 17, right, the most reactive element is fluorine, the one at the top. Most reactive means fluorine can easily form its ion. In order to become stable, it can take one electron or to form F minus, right? But when you go down the group, now if you take iodine, right, to form I minus, it's difficult because the radius increases down the group. So to add another 2 electrons and to form the minus ion will be difficult. So oxidizing agent means children, it should be able to undergo reduction. So when 0 becomes minus 1, it is known as reduction. So the ones that is at the top of the group are strong oxidizing agents. So they have given 2 reactions, one with chlorine and one with bromine. So we know chlorine is above bromine, therefore it can easily reduce than bromine. Therefore chlorine is the strongest oxidizing agent. Then we'll see the next one. To compare polar and nonpolar liquids, a stream of liquid from burette and a positively charged plastic rod can be used. Which row of the table shows the correct direction of deflection? Okay, so if you have a polar liquid, children, right, we know in a polar compound, for example, if you take HCl, we have a negative charge and a positive charge. So when you pour HCl, because of the negative charge, it tries to get attracted to the positive one, right? Therefore, you can say if there's a polar liquid, it tries to move towards the rod. If it's a nonpolar liquid, then if it's like hexane, uh, something like that, there won't be any deflection because nonpolar ones, they don't have any charges. So they will just flow without any deflection. So the correct answer is C. Then we'll see the next one. Which equation represents the second ionization energy? Okay. So if I write the equation for the first ionization energy, always we are removing an electron from a gaseous element. This is for the first ionization energy. We are removing the second electron from the charged ion to form Mg2 plus by the removal of one electron. This is the equation for the second ionization energy of magnesium, and it is given by B. Then the 11th one. This question is about the isoelectronic ions. So isoelectronic means, children, they should have the same number of electrons. So if you take sodium, magnesium, and aluminium, all three will have the same number of electrons, but the number of protons will increase by 1 each. So when you have the same number of electrons and more number of protons, then definitely the one with more protons will attract the electrons, making the radius smaller. So the correct one is aluminum will have the smallest radius, then magnesium, the largest will be sodium. So the correct answer is A. Aluminum is smallest, then magnesium, then sodium. If you take B, which ion are shown in order of increasing ionic radius. So if you take fluorine, oxygen, and nitrite, they also have the same number of electrons, but their number of protons are different. Fluorine has 9, this has 6, this has 8, and this has 7. So when you have less number of protons and more electrons, there will be a lot of repulsions between the inner electrons and the outer electrons. So the shielding effect is very high in N3, then O2, then F minus. You can see difference is 1, 2, and 3. So N3 minus will have the greatest ionic radius, then O2 minus, then F minus. Then we'll see the next one. Which pair of compounds will not react to form a precipitate? So if I write the equation, I will get silver chloride, we know it's a white precipitate, and calcium nitrate. So any nitrate is soluble. It's a aqueous one. So if you take calcium hydroxide, which is lime water, and carbon dioxide. So when you blow carbon dioxide or exhaled air to lime water, we know it turns milky white because of the formation of calcium carbonate. It's a white precipitate. So if you take barium hydroxide and HCl, you get barium chloride and H2O. Barium chloride is an aqueous solution. If you take these two, you get PbI2, a solid. It's a yellow solid. It's given in your student book under precipitation reaction. And potassium nitrate. So C doesn't give a precipitate. Barium nitrate, barium chloride, they are aqueous solutions. All the others, they have precipitates. Then 13, what is observed when iron 2 carbonate reacts with ethanoic acid? Okay, so iron 2 carbonate is FeCO3. With ethanoic acid is CH3COOH. So what will be formed? We know when an acid reacts with a carbonate, we get carbon dioxide and water. And the salt of the carboxylate ion, that is FeCO twice. Then when you have iron carbonate, it's a green solution because if we have Fe2 plus iron in the medium, it forms a green solution. And you can see the formation of a gas, therefore we can see effervescence as well. So the correct answer is green solution and effervescence. So we'll see the 14th one. Which is the simplest ionic equation for an alkali reacting with an acid? For that, children, I'll take an example. NaOH AQ with HCl giving NaCl and water. Right? So first I can break the aqueous solutions into ions. Right? Then I can cancel out the spectator ions. So the final equation is H plus AQ with OH minus AQ will form H2O liquid. The correct answer is C. Remember children, we can't write aqueous form for water. We can only write liquid and gas for water, not aqueous. Because of that only B is wrong. And they have asked for the simplest ionic equation. Because of that, A is also wrong because we can further simplify it if you divide it by 2. Then silver chloride decomposes, write an equation. So if a compound decomposes, right, we can easily include state symbols. So we know it's a white precipitate, right? You get silver metal and chlorine gas. So when you write an equation, you need to write the balanced equation, right? It will decompose into its elements. Silver can form in displacement reaction. State two observations that are made when copper metal is added to silver nitrate. So first you write the equation to see what is going to happen. Copper and silver nitrate. We know in the reactivity series, copper is above silver. Therefore, you get copper nitrate and silver metal. Copper solid, this is AQ. So in order to balance it, we need to put 2. Copper nitrate, when copper is in 2 plus form, it is blue. Therefore, you can see the formation of a blue color, and also you can see the deposition of a gray solid. When they ask you to write observation, you can only say what you can see. Don't write copper nitrate is formed and silver is formed. That is wrong. To show the formation of copper nitrate, you have to mention that the solution changes to blue, right, or colorless to blue, and a gray solid. Write an equation for the displacement reaction, include state symbols. So this is how you have to write it. So don't put, I just showed that copper has 2 plus charge. This is how you have to write the balanced equation. It's an aqueous solution. Copper nitrate. Any metal nitrate is an aqueous solution. Describe the bonding in pure silver metal. So we know silver is a metal. So when you draw the bonding, it should be a layered structure. Positive metal ions, right? And delocalized electrons. And you have to show at least 12 silver particles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then in between you have to put electrons. Otherwise, there can be repulsion between like charges. In order to overcome that, you have electrons. So for the structure, you get 1 mark. Then you have to mention, we know the bonding in silver metal, metallic bonding. So you have to mention there are electrostatic forces of attraction, 1 mark for writing that, between positive metal ions and delocalized electrons. Pure silver cups are too soft, so small amounts of copper are added to make an alloy. Explain why copper makes the silver less malleable. So children, remember that if you take the sizes of copper and silver, they have different sizes. So when you have different sized atoms in this layered structure, right, if you have another atom, then what will happen? It becomes less malleable because the layers will less likely to slide over each other. Okay, as it has added in small amounts. So when you write the answer, it will be very careful. So in the marking scheme they have given, the layers or atoms slide less well over each other because the ions have different sizes. Or you can write because the copper ions are smaller than silver ions. Or if you mention different sizes also, okay. So don't ever write the layers will not slide over each other because they have added only small amounts. So you have to mention about the layers of atoms slide less well over each other. Then you need to define the relative atomic mass. You can write it is the average mass of atoms, 1 mark. Average mass of atoms relative to 1/12 the mass of 1 atom of carbon isotope. So they have given marks for mentioning about the average mass of atoms and for writing about 1/12 of mass of atom of carbon-12 isotope. That's how you get the 2 marks. Then we need to find the mass of the sample of silicon. First thing, children, when you get a question like that, calculate and see whether they have given all the percentages. So if you take 91.07, 4.62, 3, and 1.31, everything will add up to 100. So that means only 4 isotopes are there. So we can multiply the relative abundance by their isotopic mass, 28 into 91.07, 29 into 4.62 plus 30 into 3 plus 32 into 1.31. Everything should be divided by 100 because it is given as a percentage. If they haven't given it as a percentage, children, you need to find the total number of atoms and divide it by that. So when you find the answer, you get it as 28.15. They have asked to keep it for 3 significant figures, so it should be 28.2. That's the answer for that. In the mass spectrum of silicon, there is also a small peak at 14. So children, we can see all the peaks are like 28, 29, 30 and 32. So 14 is like half of that. So all the atoms that are coming from the mass spectrum will have a charge of +1. Therefore, if it is mass is 21 and if it has +1 only, you get it as 28. But if the charge is +2, then what will happen? You can get a peak at 14. So you have to use the formula of this particle, silicon 28 and +2. Then only you can get a peak at 14. It should be 28 with a +2 charge. Consider the elements. Explain the trend in the first ionization energy of aluminium to phosphorus. So children, if I take this sodium, you have to draw this thing. You have to have a rough idea about the ionization energy graph. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and the highest one will be for argon. So if you take aluminium to phosphorus, you can see the ionization energy increases for writing that 1 mark. The reason is nuclear charge is increasing. 1 mark, and you mentioned the electrons are removed from the same subshell as they are in the third period. All the electrons are removed from the same subshell. That is for the 3rd mark. Explain why sulfur does not follow this trend. So you can see, if I show the pattern again, sulfur has a low ionization energy than phosphorus. So the reason is you have to explain in terms of after writing the electronic configuration. Phosphorus 15, sulfur is 16. So if I write it 1s2, 2s2, 2p6, 3s2, 3p6, and 3p3. Then that means in the outermost shell, we have 3 p orbitals and all 3 will be singly filled. In this, 1s2, 2s2, 2p6, 3s2 and 3p4. Then you can see it has a paired orbital. So when you have a paired orbital, there will be repulsions between the electrons and easy to remove, or you need to give only less energy to remove an electron from a paired orbital. In the marking scheme, they have given sulfur has 4 electrons in the 3p subshell and one 3p orbital has a pair of electrons. So alpha has 4 electrons in the 3p subshell. If you draw the diagram and show even, you are getting that mark. And it has a pair of electrons. If you just draw these two diagrams also, you are getting the same mark. Then you have to mention there is a slight repulsion between the electrons. There is a slight repulsion between the electrons in the same orbital, resulting in a lower first ionization energy. Resulting in a lower first ionization energy. So if you draw the structure of atom, we know in diamond, each carbon atom is bonded to 4 other carbon atoms. So if you take the middle one, we know that each carbon atom is forming covalent bonds. So it should be drawn like this. Here also, this one will also have 4 bonds with other carbon atoms. So they expect you to show that as well, because if they have lone pairs, we are showing the lone pairs. So if they have bond pairs, you have to show the bond pairs as well to complete the structure, as diamond is a giant covalent lattice. So 1 mark is given for the central atom with 4 bond pairs, and second mark is for showing the bond pairs of other 4 carbon atoms. Draw a label 3D structure of graphite showing 2 layers. So we know, children, the structure of graphite. It has a hexagonal structure. Something like that. We have to draw 13 carbon atoms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, then you have to draw using a ruler. You can draw it correct nicely. Now I don't have a ruler, so it's a little bit crooked. Then I can draw the other layer as well. Then you have to show that these are the forces of intermolecular forces or attraction between layers. Attractive forces between layers. So for drawing the hexagonal rings, 1 mark. And for labeling the electrostatic forces of attraction between the layers, 1 mark. Suggest why diamond has a greater density than graphite. So we know in graphite, there can be spaces between the layers. So when you have spaces, the density decreases. But in diamond, there's no place for spaces. Therefore, it has a high density. In the marking scheme, they have given, in diamond, all the carbon are bonded to each other with no gaps. In diamond, all the carbons are bonded to each other with no gaps. In graphite, there are layers that are further apart than the carbon to carbon bonds in diamond. Or if you mention about the empty space, or it has large distance between the layers also, you get marks. You have to mention that it has air, or it has some gaps between the carbon atoms. When you have air only, the density decreases. Then the 18th one, baking powder is added to cake mixtures to make cakes rise by releasing a gas, acidic derivatives. Seen 2 types of reaction during cooking, one of which is neutralization. So neutralization is the one where the sodium hydrogen carbonate reacts with the tartaric acid. The second type is thermal decomposition, because children, when you have sodium hydrogen carbonate, right, when it decomposes, you get sodium carbonate, carbon dioxide and water. So carbon dioxide also formed when it undergo uh, thermal decomposition. Now, after making a cake, right, if you put it in the oven, you can see that it rises again. That is due to the thermal decomposition. Due to the heat in the oven, sodium carbonate has undergone thermal decomposition to form carbon dioxide. Suggest why neutralization does not occur in an opened container of baking powder. So we know, children, for a reaction to take place, ions should combine with each other. But baking powder is a solid, therefore the ions cannot mix, or water should be there for the reaction to take place. So in the marking scheme, they have given the reactants are dry, or you can mention that what is needed for the reaction to take place. Then the next one, they have asked to find the empirical formula of the tartaric acid. So now they have given the percentages. The rest is oxygen. That means from 100, you need to subtract these percentages. Plus 25.5 plus 2.66. So when you subtract these, you can the mass of oxygen as 51.04%. Right? Then we can work it out as a normal empirical formula calculation. We have potassium, carbon, hydrogen, and oxygen. So first thing is you have divided by the atomic mass. 20.8, 25.5, 2.66, 51.04. When you divide, atomic mass is 39.1. This is 12. This is 1. And this is 16. Then you get it as 0.532. Then carbon, it's 2.13. Hydrogen, it's 2. Oxygen, it's 3.19. Smallest decimal number. So the smallest one is 0.532. So you divide everything by 0.532. Then you get under potassium 1, carbon 4, hydrogen 5, and oxygen 6. Then you get the empirical formula as KC4H5 and O6. KC4H5O6. Then we see the acidic derivative of tartaric acid can be represented by this Write the equation for the neutralization of sodium hydrogen carbonate. So we have sodium hydrogen carbonate with H plus, K plus and A2 minus. So normally what is happening here is you get the positive one, it will go with the negative one. Right? So we can get H plus will be replaced by Na. NaK plus A2 minus will give carbon dioxide and water. So everything is balanced. Because tartaric acid can donate H plus to the medium. So when it donates H plus, the positive ion in the sodium hydrogen carbonate will bind with the tartaric. Tartarate. Therefore, you get this formula. Then we'll see the next one. We need to do a calculation, right? In that, we need to find they have given the amount of baking soda as 5 grams, but only 3% is sodium hydrogen carbonate. So first, we need to find amount mass of sodium hydrogen carbonate. From 5 grams, you'll take 30%. Then you get answer as 1.5. So when you get the mass, you can divide by the molar mass. Molar mass of sodium hydrogen carbonate is 84. So then you get it as 0.01787. අපේනා කෙල්ලම 16 පටන් ගන්න කියලා. ඔව් අපේ මේ එක්සෙප්ෂන් එක 16 පටන් ගන්න කියලා. ඒ වගේ දැන් 19 Exams activate because January to come there to the and they are sure that will Oh, the January one. What is the Oh, it's so good. It's over. You start. No, no, it's a better now. Thank you.